In this session, we are going to discuss about kinetic energy. The objectives of this session are to understand about kinetic energy, to derive an equation for kinetic energy. First, we need to discuss what is kinetic energy. Kinetic energy is energy of an object because of its movement. All moving object is having kinetic energy. Moving car, moving bus, moving ball. All moving object is having kinetic energy. This ball is moving. Because of this movement, this ball is having energy. That energy is kinetic energy. This car is moving. Because of this movement, the car is having energy. It is also kinetic energy. So we can conclude that moving object possesses one energy. That energy is known as kinetic energy. It is the energy of an object because of its motion. Now we can derive an equation for kinetic energy. For that, we are going to consider an object, a ball of mass m. Consider an object of mass m at rest. It is a ball, and the mass is m. At rest means, what is its velocity? 0, because it is at rest. Rest means no movement, so initial velocity is 0 meter per second. The mass is m. When we are applying an external force, here we are applying an external force. When we are pushing that ball, it will move, right? Ball is moving because of an external force. Here we are applying an external force, so it is moving. Now the velocity is not 0. Now the velocity is v. We don't know the value, so we are taking v. The mass is m, u is 0, initial velocity is 0, final velocity is v. Displacement from here, this point to this point, the displacement is s. Because of the force, it is displaced from initial position to the final position. There is an equation, v square equal to u square plus 2as. What is the value of u? U is 0. So it will be v square is equal to 2as, because no need to write this u. From this equation, how we can make an equation for a? 2 and s, here it is multiplication. When we are taking this 2s to the other side of the equal, it will be division. We are keeping a here, and this 2 and s we are taking to the other side of equal. So it will be division. It will be at denominator. A equal to v square is there by this 2s. Now we got equation for a equal to v square by 2s. We know that work done and energy both are same. The unit of work done and energy is same. To find expression for energy, we need to find expression for work done, because both are same. Work done equal to, what is equation for work done? Work done W equal to force into displacement. According to Newton's second law, what is equation for force? Force equal to ma. So instead of this force, we can use ma. So, and instead of displacement, what we can use? The displacement is s. Work done equal to ma into s. Work done W equal to ma into s. Here, instead of force, we are using ma. According to second law, instead of displacement, we are using s. We already derived an equation for a. What was that? A equal to v square by 2s. We are going to substitute this equation in this equation. Then it will be work done equal to m into, instead of a, what we can write here, you can write v square by 2s into this s will be there. There are 2s now. We can cancel these 2s. Then equation is work done is mv square by 2. You can write the equation like this. It is half, right? mv square by 2 means it is half. So we can write that half to the side of the equation. It will be half mv square. Work done is kinetic energy. Then equation for kinetic energy will be half mv square. It is a final equation. M is mass, v is velocity. If we know the value of mass and velocity, we can find kinetic energy.